Okay, class. Today we're going to talk about base theory. Does anyone ever heard of base theory? No? Okay. Well, let's imagine a scenario. You're just casually walking on the street and you come across a guy. Now, the question is this guy more likely to be a teacher or more likely to be a farmer? You might think, what a strange question, and you didn't give us enough condition to determine. So, okay, back in the scenario. After a short conversation, you find out this guy loves reading and even have a bachelor degree. Plus, he's wearing glasses. Now, let me ask you again, is this man more likely to be a teacher or more likely to be a farmer? A teacher, you might say, but since we're in a math class, we have to find out in a mathematical way. So, let me draw the graph. Okay, this is all the population of teachers and farmers combined. And according to the statistic carried out by Executive Yuan, the ratio of farmer to teacher is 10:1. So here, this left-hand part is teacher, okay, T for teacher, and the right-hand part is for farmer, F for farmer. And since he likes reading, what percentage of teacher do you think he likes reading? Let's say about 80% here. So the colored area is the one being teacher and loves reading. They say R. What about for farmer? They say about only 30% here. Okay, so I believe this model can already tell the result, but since others don't, we have to keep going. So the probability of one being teacher and love reading equals to, I didn't give the numbers, but it's 1 out of 11 times 80%. And this equals approximately to 0.07. And the probability of one being a farmer and loves reading equals to 10 divided by 11 times 0.3. And this equal to 0.27. So the probability of teacher, given that he loves reading, equals to 0.07 and 0.07 again, plus 0.27. And this equals to 0.21. Only about 1 in 5 person that likes reading is teacher. How unlikely. But what makes our expectation wrong? We have to find out. So let's write this in a more common way. P, the probability of A given B, equals to P, A, and B, and divided by P of B. And this one equals to P of A. P of A times P B given A. And the denominator is P A times P B given A plus P of not A. In this case, is farmer. And times P B given not A. What does this equation tell us about? Okay, so I give you the condition he loves reading. Most of you guys think that, oh, so this is the prior probability times the condition I give you. But most of you don't think about is that the denominator, since the ratio of teacher to farmer, the farmer is way more than the teachers. So this here actually decrease the probability of the teacher and given that he likes reading. So the part right here. Oh, let's give it another color. The part right here is what we call the Beth theory. And the lower part here is the heart of the Beth theory. But I don't want you guys to memorize this. Instead, I want you guys to memorize this, since this gives you guys a more visible way to comprehend the concept behind the Beth theory. See, the ratio between farmers and teachers right here, and those like reading. Yeah, since this is a more directed and the easier way to understand. But since we live in a country, judge student by test and the score, we have to do some calculation. So yeah. Well, here the question is, there is a virus spreading among the country. I didn't say what country, and about 2%. About 2% in the country. About 2% of the population in the country is affected by the virus. And today, the country invented a new test to find out whether the person is affected or not. If an affected person takes the test, let's say affected. Okay, I leave it blank. Okay, affected taking the test, it will have 97% that the result is positive. Let's say P-O-S-T, positive. Positive means that the test says that person have been affected. So, but on the other hand, the probability that a non-affected person taking the test, and the test the result is positive, the probability is about 9%. So today you taking the test and the result is positive. Let's say given positive. So how likely are you really getting the virus? So the probability of infected given that positive. So according to the formula here, lower part will be better. So yeah, the probability of infected person given that is positive equals to 0.02 times 0.97, and the denominator is 2 times 0.97 plus those are not affected. It's 98% times the result being positive is 0.09. A little bit ugly, but hope you don't mind. And this result is equal to 80%. Just 80%. The result says you are positive, you are being affected, but the accuracy is only 80%. Imagine one may getting a result being positive, he may spend all his money just to cure the disease he not likely to have, or even begin to settle his own affair. This is ridiculous. So remember, always remember, making the decision, do not making the decision without thinking twice, okay? But what are the other cases or other situations that Beth theory may come in handy? Well, let's say Indonesia. Most of Indonesia are Muslim, right? Those Indonesian you see on the street are very likely to be Muslim. In fact, most about 80% of the Indonesian population are Muslim. So let's say here, Indonesian. Are Muslim. Does this yield to all the Muslims are Indonesian? Of course not. That's because we know the global population is, as for now, is like 8 billion. But the population of Indonesia is only about 217 million. This is a little number, but compared to global population, that is not worth mention. And the other cases is COVID. So I do with or survived COVID. Do you guys getting vaccinated? At least I do, and I believe most of you do. So, according to the statistic, most of the confirmed cases, let's say confirmed case of the confirmed cases are vaccinated. Does this mean getting vaccinated make you more likely to get COVID? Do you think this is true? Of course not. This is opposite the purpose of getting vaccinated. But why? Why most of confirmed cases are vaccinated? That's because the population, let's see P, these things they are equal. The P of getting vaccinated is way more than the probability or population of not getting vaccinated. So, in fact, most of the people in Taiwan are getting vaccinated. It's like about 95%. And those who not left only 5%. Yeah. And the purpose of getting vaccinated is not preventing you from getting the COVID. It's preventing you from death because of the COVID. So, yeah. So don't be fooled by this condition here. Don't be fooled. So at the end of the class, what we learned today, we've learned about Bayes' theories formula, the heart of the Bayes theory, but most importantly, it's not most importantly, more importantly, this graph right here, since it's graph, once again, gives you a more visible way and an easier way to comprehend the concept behind the Bayes theory. But the most important thing is that it's a lifetime advice. Always think twice before making any crucial decision and use a mathematical method to prove your point. That's it for today. See you tomorrow.